Hello and welcome back to Multibiomics. So this is the first video of this series, and we are going to see the coding tutorial for the basics of R for computational biology series. Now this is the first one in the playlist, and as the classes commences further, each video will be added one by one. So we are going to learn this video how to set up our R environment for genomic data analysis and then move on to working with real tabular genomic data. By the end of this session, you'll know how to install both CRAN and bioconductor packages, read and write genomic tables efficiently, save and reload R objects safely, and handle genomic specific formats like bed files using the RTrack layer package. All the scripts used here are available on my GitHub repository, and I've also linked the Google Classroom and free textbook PDF file in the description box below. So don't forget to check that out. And if you are not familiar with how to proceed further with this series, I urge you to go through the previous lecture video, and you'll get familiar with my GitHub repository and also with the Google Classroom environment, where you will get all the necessary materials and links and announcements there. So you can see the RStudio window in my screen now, in your screen, sorry. So here the script itself is self-explanatory. The comments will tell you that what we are doing over here. So here first we are going to learn how to set up our R environment for genomic data analysis, and we are going to use CRAN and bioconductor packages, right? So the first is we are going to set up our environment, and for that we are installing some packages. If you don't have these packages, please follow the script. So install.packages, and we are creating a list of packages that you have to install. So like this, by using this syntax or this format, you can download multiple packages at the same time. So we are using data.table and readr. Now these are the commands that we are using here now. We'll be using them. Now these serve as the fast alternative to the basic R commands for reading the tables, right? And you will also be installing the bioconductor if already not installed. So most of you might be already having bioconductor. So if you already the package is installed in your system, so it will quietly move forward to the next command. Okay. Now here from the conductor, by using BioC manager, we are installing another package that is RTrack layer here. And why we are using this? For handling bigger file formats like BED. So we'll be using BED file over here, GFF, BigWig, etc. So these are the genomic data table formats. So let's start with the basics. We'll practice the basics here. We'll learn how to create a genomic table in R, right? How to create a genomic table in R. So first we'll be creating the table in the R environment itself, and then we'll write it to the disk. That is, we'll write it, we'll make a file in our system, and then we'll again read the same table from the system itself, not from the R environment here. So these three things we'll be doing over here. So what core skill you are learning? The core skill that you are learning here is how to handle, create, write, and read the tabular genomic data. So reading and writing basic tables is the next section. So here we are creating a toy genomic table with columns. The columns are, the first columns will be chromosome, the second column will be start position of the chromosome, then end position of the chromosome, and then we'll be having an arbitrary score. This score can be your coverage or the signal intensity, whatever practical thing that will be encountered by you by your workflow, right? So the table that I'm creating over here, I'm creating it under the name of DF, and I'm storing that as the data structure, that is data frame. So data frame is a tabular structure of data. So here we are defining the first column. So under chromosome, we will be having 3 rows, and we are naming the chromosome as chromosome 1. Uh, Here, chromosome, sorry, so chromosome 2, and here as chromosome 3. Now, in the next column, start, so we have some starting position of the chromosome, and in the end, the ending position of the chromosome, and we are assigning some arbitrary score over here. Okay, and here strings as factors. So these are some data types which I'll be explaining it to you in upcoming videos. So we'll not take them as factors, right? Will not assign a class to this. So these are just strings, right? So don't worry about this line. We'll be learning it in the next video. So here, first let us create this table. So just select it, and I'm going to run this. So here you can see in the R environment, there are 3 observations that has been created, and there are 4 variables. So if I click on this, I can see this toy data table getting created, where the first observation is first chromosome, chromosome 1, the second one is chromosome 2, and the third one is chromosome 3. And we have got 4 variables that we have got the name of the chromosome, and we have got the starting position and ending position, and then we have got a score, right? So this is the data table that you have created. So you can see the syntax over here. Now you can see what is CHR1, CHR2, CHR3 is the names of the chromosome, and we are using this C command over here. So everything in detail we'll be learning, but this is just the warm up, right? Don't worry if you don't know what is this C. No worries, please check on the next video. Everything will be explained, the data structures and the data types, everything will be explained in the next video, right? So here, so basically you just see how the table has been created in the R environment. Okay, so now this is the base R command, like how to create a table. So the read R table and read dot table and write dot table are the basic R commands. But if you're working with the larger genomic files, these are very slow commands. It will take a lot of time for you to read and write the tables. So there's a faster alternative, that is fread and read underscore tsv. And these commands are optimized for speed when you're working with the larger files. So reading and writing becomes much faster. The genomic tables that you're reading and writing, it becomes much faster. So now what we are doing, we are using the data.table and read our packages now. So these are the 2 packages that will be these are the 2 packages that you'll be using for speed. Okay, so before that, let's write the toy data to the disk first. So we are writing this table now. The table that you have created, the data frame that you have created, that is DF. Okay, if I click on the DF again over here, you can see this one. What we are doing, we are making it as a txt file now, and we are naming it as toy underscore data.txt. So when you're using write.table command, which is the basic R command, right? So you have to specify which is the separation of the columns. Like we are using this tabular separations, right? Now read it back. Now we'll read it back. That means you'll read again the same table, but we'll be reading it using this file that you have created. So first we'll run this command. Let's run it. And you can see in the working directory that a toy.data.txt file has been generated. I have clicked on it, and you can see this file has been opened. So this is just a text file, and each columns are separated by using a tab character, right? Sorry, a tabular space. Right. Now, I'm reading the same table that we have created just now. So I'm using read.table, and now I'm writing the name of the file. So if your file is generated somewhere else and not in the working directory or in some subfolders or subdirectories, You can write the whole path or the relative path, and because it is in directly in my working directory, I'm only writing the name of the file over here. It'll load. Okay, but if suppose it's not in your working directory or in some other directory, in subdirectory or the subfolders, then you can use the relative path too, right? And if you cannot understand any of the things that I'm saying, you can please ask me in my Google Classroom or in the WhatsApp group that you have already joined. Now here we are reading it back, and now we are reading it under the name as df2. So if I'm running it, you see the another object has been created with again 3 observation and 4 variable, but now it is reading using the txt file that we have generated. So if I click over here, you see the table, same table appears. Fine. And if you want to print this in your console right here, we can use print command, and we can write the name of the table or the genomic data that you have created. And when you run it, you can see it is coming here down in the console. Okay, now we'll be using data.table and reader packages. And these are for faster data handling of the genomic data tables. So first we'll be loading the library. It is very important you load the libraries that you're using first. Load the packages using this command right over here. So here we are loading data.table package, and we are loading reader or reader. So just select it and run. The packages have been loaded, and now first we'll be using from the data.table package, we'll be using the command fread, and from the reader package, we'll be using the command read_tsv. So these are faster alternative. Now, the link to this file is provided in the script itself down below in the comments. I'll just tell you where they are. So I have already downloaded. You can see in my working directory known gene.txt.gz. So it's a zipped file. You have to unzip it, right? And just store. When you're using fread to read this table, I'm using this variable name, that is df_dt, and when I'm using read_tsv command to load the same file, I'm just saving it in another name. Okay, because later on what we'll be doing, we will be comparing the time taken to read these files by the different commands. So just load this. Just read this table. Let me not print this first. First, using fread command, let us read this data table. I'm running it, and so now, if you can see over here, this data table is quite huge: 381,987 observations and with 12 variables. So you can see there are 12 columns over here, and there are so many rows. The number of rows that you can see. Okay, so it's a fairly larger file, and that's why if you want to visualize that, you can print it. I'll not print it right now. Now, by using the different command, I'm loading the same file again, and the name is different, that is df.rr. So from rr, I can understand that the command that I've used is read_tsv. Right. So till now, what we have done is till now we have used 3 commands. The first command is read.table. The second command is fread, and the third command is read_tsv. And now what we are going to do is let us compare the amount of time taken to load this particular data. So the data that we are again loading is the known gene.txt, which is a huge file. So let us run this. Okay. So the command that we are using is system.time, and the time taken by the command read.table to load this known gene over here. And the second one is system.time and time taken by fread, and system.time command is using to estimate the time taken by read underscore tsv. And here we are going to load the same file, right? So running it. Fine. So it has been run, and we'll see what is the estimated elapsed time that has been taken. You see here, right? Here we can find out the time. So read.table took 2.33 seconds to load a huge file, which is not bad. But when you compare it with the time for fread, so fread is taking 0.33 seconds total time to read this data, and the read underscore tsv is taking 0.4 seconds. So by comparing, I've compared them again and again. So every time I've found that fread is quite faster, and when compared to the other two, and the base r command, that is read.table, is quite slow. So these are some faster alternatives for like fread and read underscore tsv. So for that, you have to also have the packages installed, right? So the packages were data.table and readr. Okay? So data.table gave you fread and readr gave you read underscore tsv. So these are the faster alternative to read bigger genomic files. So now we'll be moving on with another set of exercise. We'll learn how to save. Suppose you have done your work, now you want to save your work as R objects. Then what we'll do after saving, suppose in near future, some days later, you need to load those objects again, or the next day you need to load the objects again. So these are some things that these are some basics that you should know in R, right? So the first one is save multiple objects together into one single file. So what we have got our toy data frame as df. So here you can see this is df, right? Yeah, this is df. And then second one is df underscore dt. So what is df underscore dt? This larger file over here. Okay. And okay, so these two files, these two objects. So these are the two objects that you have. So there are total 4 different objects in our environment. Now we want df and df underscore dt to be in one single file. And that file name we are assigning as objects.rdata. So the extension should be .rdata. R and D must be capital. And whatever name you want to give to your file, you can give it over here. So I'm using objects, right? You can give ABC, XYZ, whatever you want. So you can change this name over here. But I'm not changing it. I'll run this. Fine. So you can see, and .rdata file has been generated over here, which you can load later on whenever you are sitting in the next session, right? Now, suppose now you have created a file. Now you want to remove these two because anyway you will be loading it later. So you want to free up some memory. So what you can use, we can use rm command, that is remove command. And if I run this, first take a look at the environment. We have df and df underscore dt. So if I run this, you see, now we have only other two objects, and these two objects are removed. So first I have removed those two objects. Now if you want to reload those, we have already created that .rdata file, right? So if you want to load that objects, you have to use the load command, and inside the brackets you have to write the exact name of those rdata objects that you have created. So here I'm using this. Now, one more thing, if you use this method like save command and then you're using load command. First, you're saving it using save command. Okay, and then you're using with the help of load commands, what happens then? You don't have the flexibility of renaming them. So whatever name has already been given before, uh, the data will be stored via same name itself. So I'm loading it, you see. I'm just running it. Same with the same variable name, the data has been loaded. Why it is possible to load data now? Because you have created the objects over here. You can name according to your own wish. But there's a safer alternative by using save RDS. What happens first if you have saved? Now let us save our DF2. So this one, DF2. If you want to have a look, this is the DF2, the toy data that you have created. Okay, so this one. I'm closing these tabs. Fine. So instead of using save command, I am using save RDS command. I'm running it. So there's another object that has been created now with the extension .rds. So it's a different type of file, that is a .rds file. Now what you do, if you load this object, this RDS object, so save RDS will be, if you want to load them, you have to again use read RDS. Now you can control, you have the control over the variable name this time. So you can rename the variable. You can load the same data that you have generated, but what you can do now, you can rename it accordingly. Suppose if you are using the same data but you are following a different workflow, now you want to rename them, so you have the freedom of renaming them. Okay, so here, so now what I'm loading df2, but now I'm renaming it as obj. It's a short form for object. So running. So you see there's another environmental object created over here, same thing but under different name. If you want to print it, you can print it and you can visualize in the console itself. It's the same thing but now the name has changed. So this freedom you have if you use same RDS object, right? So this section is over. So now that we have covered the general data handling, let's move on to genomic file formats. We are using our track layer package and we'll export our toy genomic data as a particular file known as BED file, and we'll also import it back into the R using by using this particular file that we have generated right now. Okay, so moving on with my script. So first you have to load this library R track layer, run them. Okay. So I'm getting some errors. Yeah, no errors. No, these aren't errors. Okay, so first now we'll be exporting a genomic table. We'll make a genomic table. Already we had made one, so we'll be using this toy data itself, but now we'll be exporting it into another format. So we had generated this as a text file earlier. So we had this toy data.txt. Now we'll be making it as a bed file, a BD file. So for that, we are using export command, and in that the very first data that we had generated, that is under the name df. Okay, so df, and now we are naming it as toy underscore data dot bed, and we are specifying the format here as it is a BD file, right? So just run it. It has been exported, and you can see in the working directory, so toy underscore data dot bd file has been generated. The difference in the size also is visible over here. Now let us import this BED file back into R. For that, so I'm importing it under the name BED, and the command that I'm using is import command. So just specify the file name and format is equal to BED. So just run this one. Okay, so you can see in the environment, the object named BED has been imported, right? If you see this, so the different elements you can see, the values, ranges, what are the strands. So obviously the format is different. So it's not a simple data frame, but under a very different format. And if you want to visualize that, just visualize it in the console. BD over here, you can see, you can read. So three ranges and two metadata columns. Okay, so it's much more detailed when it comes to genomic data table. So people who cannot understand what is the BD format, there's a topic for another video, right? Now there's an exercise for you. Import a GDF file, okay, and extract all the entries from chromosome 1 and write them into a new GDF file. If you know how to do this, it's well and good. If you don't know, let's do this exercise in the next video in the series. So there'll be two more videos coming up. One regarding this exercise, and then the other video where we'll be discussing the different data types and data structures that we'll encounter, and the BED file, a little bit about the BED structures here, BED file format, right? So this is it for today's video, and I hope you have learned something. If there's any suggestions to improve this video, you can just tell me. If you did not understand any of the concepts, just contact me in my LinkedIn or through the WhatsApp group if you have already joined, or from Google Classroom, right? So that's it for today. Have a nice day.